Okay, today we're going to look at something just a little bit different. It's called the remainder theorem. And I think you're probably going to be surprised what comes out of this. The thing says, if you take a polynomial and you divide it by x minus c, then f of c will give you the remainder. Let's take a real simple example of that. Suppose that I've got x squared minus 6x plus 4. And I'm going to divide that by x minus 1. Now, we know how to do long division for that. So if I take x minus 1, and we do our long division, then this goes x. I have x squared minus 1x. Change my signs. I have minus 5x. I bring down my 4. And then x goes into minus 5x minus 5 times. I get minus 5x plus 5. I change my signs. And I get minus 1. Minus 1 is my remainder. But in our problem right here, my f of x is x squared minus 6x plus 4. Now, I'm dividing by x minus 1. So we're going to find f of 1. That's 1 squared minus 6 times 1 plus 4. So this gives me minus 6 plus 5, which still gives me that minus 1. So if all you're looking for is a remainder, this is the easiest way to find it. You simply plug in whatever makes your divisor 0, and this will give you the remainder. Now, I noticed one of your homework problems. Force Compass gave you a problem like this. He said x squared minus 2x minus 6 is equal to 0. And he said, give an exact answer. Well, an exact answer says that you're going to have, if it don't come out to be a whole number or a fraction, then you're going to have to leave it with radicals, because if you put in, say, the square root of 5, that's not an exact answer. It's going to be an estimated answer. I'm going to cheat a little bit, and I'm going to go back and I'm going to work this problem by completing the square. I look at this number, half of 2 is 1. So I'm going to add 1 to both sides. So this side factors into x minus 1, and that's equal to 7. Now it's easy to take the square root of both sides. So I get x minus 1 is plus or minus the square root of 7. So I get two answers. I get 1 plus the square root of 7 and 1 minus the square root of 7. Those would be the two exact answers. So be careful when you're trying to put the answer in the correct notation here. Okay. We said that this was the remainder theorem, but it's also can be souped up a little bit, and we can call it the factor theorem. Because if my remainder is 0, then I have found a factor. Let's take a very simple example of that. Okay. Let's do f of 1 for this thing. So it's going to be 1 minus 5 plus 4. That gives me 0. So that says that when I plugged in 1, I got a remainder of 0. Well, when I get a remainder of 0, that says that x minus 1 is a factor of that. Well, look at the original problem. I'm getting a little bit lazy now, but I can factor this thing. The factors of 4 are 4 and 1. Both of these are negative. So the fact that 1 made it 0 told me that x minus 1 is a factor. Also, if I plugged in 4, this thing would come be 0 because x minus 4 would be a factor. Now, your homework problem gives you something like this. Is x minus 2 a factor of 4x cubed minus 3x squared minus 8x plus 4? Now, here's what the problem is. We want to know, is this thing a factor of it? Well, the easiest way for us to do that is just simply do f of 2. Now, f of 2 for this problem is going to be 4 times 2 cubed minus 3 times 2 squared minus 8 times 2 plus 4. So this gives me 4 to 8 is 32. And 4 and 3 is 12. 16 plus 4. So if I add my 32 and my 4, I get 36. Add my 16 and my 12, and I get 28. So f of 2 for this problem is going to be 36 minus 28, which comes out to be 8. Now, that means that it's not a factor. And it's not a factor because the remainder didn't come out to be 0. And you have a couple like this. Okay, the next thing we want to talk about are the possible rational roots. Possible rational roots. Okay, the possible rational roots of any polynomial function are factors of the last coefficient or last number divided by the leading coefficient. So for our problem right here, the possible rational roots are going to be plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 6. Now we're lucky because this leading coefficient is 1, so I don't have to worry about dividing each one of these 1 because it's only going to give me whole numbers anyway. Okay, now this is my equation. I want you to notice that we can't factor this thing because it's a cubic equation and we have enough trouble trying to factor even when it's quadratics. So we've got a couple of choices, and probably the easiest choice, let's just try some of these numbers. Let's do f of 1. Okay, so f of 1 for this problem is going to be 1 plus 2 minus 5 minus 6. And we can easily see that that doesn't come out to be 0, so we don't have to worry about it. Now, let's do f of minus 1. F of minus 1 is minus 1 plus 2 plus 5 minus 6. Whoops, 5 plus 2 is 7, minus 1 minus 6 is minus 7. So that comes out to be 0. So we have found an answer. Minus 1 has to be one of our answers. Now, the next thing we're going to learn, we're going to take an easy way out to show you how to get those other answers. But for this one, we're kind of trapped into it. Okay, so we found out that minus 1 works. Let's try 2. Well, if I try 2, I got 8 plus 8 minus 10 minus 6. I get 16 minus 16 is 0. We're getting extremely lucky, okay? Now, So the only other possibility would be 3. Now, all we have to do is to decide whether it's going to be plus 3 or minus 3. And I'm going to cheat just a little bit. We found that minus 1 worked, so that means that x plus 1 is a factor. We found that plus 2 works, so that means that x minus 2 is a factor. Now look at this tail end number here. This tail end number was minus 6. So to get my tail end number, I got to have 1 times 2 times something over here. So that's going to have to be 3. Now let's get our signs right. This last number right here was a minus 6. Well, I got a plus 1 times a minus 2. And the only way that I can keep that minus is to put that to be a plus. So that says then that my third answer to this thing has to be minus 3. Okay. Now we're going to do something that for some of y'all has probably been a long time ago. And that was what we call synthetic division. Now let's take this same problem. And let's work it by synthetic division. Synthetic division says, first of all, put all your powers down in descending order. So I got x cubed, x squared, x, and then no x. My first coefficient here is 1, and then 2, and then minus 5, and minus 6. Now, we're going to cheat because we already know some of the answers that work. We found out that, for instance, that minus 1 worked. So I'm going to use minus 1 out here with my synthetic division. Now watch what happens. You always bring down this coefficient first, and then you start multiplying. Minus 1 times 1 is minus 1. Make no sign changes. 2 minus 1 is 1. Minus 1 times 1 is minus 1. Minus 5 minus 1 is minus 6. Minus 1 times minus 6 is plus 6. And just as we predicted, that remainder came out to be 0. Now, the good part about synthetic division is that we started off up here with x cubed. So this line down here is what we call the reduced polynomial. And that's the way I want y'all to look at it. When you can get it down to x squared, then you take the easy way out. So when I take the easy way out, that says that this is 1x squared plus 1x minus 6 is 0. Well, the only factors that I can use here are 3 and 2. And this has to be plus and this has to be minus. So this says that I get an answer of minus 3 and I get an answer of plus 2. And if you'll think back, that's the same 3 answers that we gave a while ago. So synthetic division is a great tool for getting those other answers. Now, I wish I hadn't put this in the way right here because we could have kept going with synthetic division with this thing right here. Let me show you that. I have 1, 1, minus 6. Now, that's this line right here. So let's try a 2 on this. I bring down the 2. 2 times 1 is 2. 3. 2 times 3 is 6. And just predict it. It gives it to us. Now, let's try minus 3 right here. So I can get all 3 of my answers by going all the way down using synthetic division. My recommendation is that I always get it down to a quadratic, and when you get it down to the quadratic, you go back to the second or the third day of class, and you either factor, complete the square, or if you have to, use the quadratic formula. Rarely will they make you use the quadratic formula because the numbers Now we're going to cheat just a little bit because the possible rational roots of this thing are very, very easy. The only factors are 2 or 1 and 2. So plus or minus 1, plus or minus 2. Okay, so let's do synthetic division since it's set up in the correct form. Highest power is 4, 3, 2, 1, and then none. So I got 1, 1, minus 3, minus 1, 2. Okay, I'm going to cheat just a little bit before I start this and try to do something in my head. So if I try 1, this is minus 4 and plus 4. So 1 is going to work. Okay, so always bring down this lead coefficient. Now you start multiplying. 1 times 1 is 1. 2, 1 times 2 is 2, minus 1. 1 times minus 1 is minus 1. 1 times minus 2 is minus 2. And we got very lucky because it did work. Now, let's try 1 again. There's a possibility that it would work again. So bring down the 1. I got 1. I got a 3. I got a 3. I got a 2. 1 times minus 2 is 2. So we got extremely lucky. Now, stop and look at this thing. We started off up here with x to the 4th. The highest power of the next line is x cubed. So the highest power of the third line is x squared. And that's what we want. My reduced quadratic is this line right here. So this is 1x squared plus 3x plus 2. How nice that is, because the only factors are 2 or 2 and 1, everything positive. So I got x is minus 2 and x is minus 1. So this thing had 4 answers, 1, 1, minus 2, minus 1. Now I want to warn you ahead of time. When you're recording this answer for Course Compass, be very careful and see if he writes the 1 down twice. He may write the 1 down only 1 time. But in reality, it's supposed to be twice because you had 2 factors of x minus 1. Okay, this one's a little bit tougher. And the reason that I can see this tougher real quick, like, because this thing has a lead coefficient of 3, which means that I have fractions that can be involved in writing and getting this answer. And what makes it even worse than that, when you plug in 1 real quick in your head, you realize that it doesn't work. And you put in minus 1, it doesn't work. So the next thing you would try would be 5 or minus 5. And we're not exactly sure which one of these does work. So let's try synthetic division with this mess. Okay, we've already said we know that the simple ones, 1 and minus 1 and so forth, are not going to work. So let's try the complicated ones now. It's factors of 5 divided by factors of 3. So 5/3 is a possibility. 5/3 looks pretty good. Let's give it a try. And I won't make any promises right now. 5/3 times 3 comes out to be 5. And minus 1 plus 5 give me 4. So that's not going to work. So let's try minus 5/3. So if I try minus 5/3, minus 5/3 times 3 gives me minus 5. And now we're off and running because this is going to give me minus 6. Now I got 5/3 times 6, and that's going to give me 10. And so this gives me minus 5. But then I still get in trouble because the 5/3 times the -5 doesn't give me that whole number that we needed. Let me look at this one close again. -5/3. That's going to give me a +10. Okay, so let me start over again. Let's do 1 minus 1 minus 55. Okay, so let's try 1/3 and see what happens. 1/3 times 3 gives me 1. This gives me 0. 1/3 times 0. This gives me -15. 1/3 times -15 gives me -5. We got very, very lucky. 1/3 is one of my answers because it gave me that 0. Now, look at this reduced polynomial. It's 3x squared plus 0x minus 15 is 0. Well, the good part about it, 3x squared minus 15x, the easiest way to solve that is simply bring that 15 to the other side and divide by your 3. So x is plus or minus the square root of 5. So if we hadn't stumbled across that 1/3 pretty quick, we could have been here for a while with this one. Because look at the other two answers. The other two answers, not only are they not rational, they are irrational. They're the square root of 5. We never would have done enough trial and error to be able to put that in. And the last thing that we're going to do is something that we've already done earlier. We jumped this thing up to a 4th degree. And it looks like that would be, first of all, using trial and error and the reduced quadratic is not going to work. So we're going to just try to factor this thing straight out. So I got x squared and x squared. And then I got 125. So the factors of this, of 125, 25 times 5, give me the 125. So let me change this middle number so that I can make this thing something that's livable with us. This is minus 125, so this is a minus 20, which means I copied the problem down wrong. Okay, so this thing will factor. I have a minus here and I have a plus here. Now look what happens here. You got x squared minus 25 is 0, and you got x squared plus 5 is 0. But the left one is very simple. X squared is 25. X is plus or minus the square root of 5. X is plus or minus 5. So, and that was something I didn't mention a while ago. The possible rational roots doesn't say that they're all going to be rational. And here's a perfect example right here. You solve this part of the problem, you get x squared is equal to minus 5. X is plus or minus the square root of minus 5. So x is plus or minus I times the square root of 5. So not only is it irrational, but it's also imaginary. So we got one more section to cover. That's section 5.6. and I'll do it Thursday with you, and then we'll talk about review and getting ready for the next test. Good luck.